days I'll buy curtains, but it's really not a priority in my life right now. So today we're going to start to talk about trig functions. So in trigonometry, we have these 6 trigonometric functions. They might sound a little bit familiar to you from good old geometry, sine, cosine, and tangent, or if you can remember SOHCAHTOA, we talk about that later. So we'll talk about them. You can use this as reference. So as of right now, you don't need to memorize anything. As we're using them more, we'll get used to them. But for now, just make sure everything's organized so you can refer back, especially since we have these big old breaks in our lessons. Just so if you see something in the future, you know what to refer to. So we've been talking about sketching angles. We did that last section. We had our little assessment on it. So let's say I'm just going to sketch an angle. Let's throw that angle there. Okay. So we say from here to here, we call that angle theta. So if we don't actually know what it is, theta is just like a general name for an angle. So now we want to start making triangles. So that's exciting. So what we're going to do for now, I'm just going to pick a point on this ray. And from that point, I'm going to draw a vertical line down to hit the axis. And I'm going to draw a line over. And what that does is it makes a 90-degree angle. So we now have a triangle. That's what trig is all about. So in this triangle, we have 3 things. Since this is on the x-axis, we call it the x. This is vertical, like the y-axis, so that's our y. And we call this our r. That's kind of our hypotenuse. So we are going to be using triangles. They can be in any quadrants, though. They can kind of move around depending on where your angle is or where your point is. We're going to be labeling x, y, and r. And we are going to use those to fill in our trig functions. So our trig functions, this first one, just be careful. This hurts. When you're a trig teacher, this hurts your heart. If someone calls this sin, that's not sin. We call this, so I'm going to put actually how we pronounce it. That's called sine. Okay? And when I say what is the sine of theta, we would say it is y over r. So I asked you, how do you find sine? You would say find the y of that triangle and then put it over the r, and that would be your sine. So this is not called cos, it's called cosine. We're just writing kind of abbreviations, but we're saying it correctly. And cosine is the ratio x over r. And once again, we don't say tan, we say tangent. And that is y over x. Now the nice thing about these, there's 6 of them. So those are the kind of, I always call those like the original 3. That's kind of our base. The other ones are kind of based off those. We call them reciprocals. So this one, once again, we don't say CSC. This is called cosecant. So the cosecant is just the reciprocal of sine. So if you think about sine as being y over r, this is r over y. The rest of them are you're just kind of flipping. This one is called secant. And that is r over x. And last but not least is cotangent. And that is x over y. So the nice thing is once you know those 3, the other ones, you just kind of flip them. So it's not like you have 6 things that you really have to remember. It's the 3, and then you flip for the other ones. So I'll leave that up for a second. This is like super important stuff we're going to be basing off of for the next few weeks. So just make sure you have it written down. So I'll give you a second. I'm not trying to rush you. Okay, so there's one other thing. So when we're using these 6 trig functions, we either need x, y, or r. And a lot of times if we're given information, we only have 2 pieces. So if we ever have to find missing info, or if you need to find a missing side. You are going to use this kind of quick little formula. X squared plus y squared equals r squared. Does anyone remember, what does that look familiar to from in your past math classes? Does anyone remember the name of it? Pythagorean theorem. What do you think if we're remembering them? Makes my heart happy. Remember Pythagorean theorem back in the day, a squared plus b squared equals c squared? It's the same exact thing, we're just changing the variables. But same, if you have a right triangle and you have two sides, you can find the third by using the Pythagorean theorem. So that's all this is, but it just relates it to the variables that we're using. Once again, I don't see you for a week. You will have to do, one of the assignments will have to do with this, so please just write this down. It will help you. Once again, for an assignment, you're just trying your best. So have the information out, do your best, and then we'll go from there. I'll give you one more second in case I don't want to rush you. We're just going to look at maybe like 2 examples together. We'll try one, and then we'll be on our merry little way here. All right, so I'm going to move it down a smidge here. So you guys all have that to refer to. And I'm going to look at example 1. Okay, make it a little bigger here. So for example 1, you guys can read it probably a little better on your paper. It says the terminal side of an angle, with theta, in standard position, okay, so that's a lot of words. We'll kind of talk about that, what that means in a second. Passes through, the main thing I want to know is the points. So the point is 8, 15. We're going to find the values of the 6 trig functions of angle theta. Okay. A lot of words, but I'll show you the setup. It's not too terrible once you see it. So what it's saying is, we're going to draw an angle. Its terminal side, so kind of just where you draw that ray, is going through the point 8, 15. So I'm just going to do a quick little sketch. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I have this point. It doesn't have to be perfect. I'm just doing a quick little sketch. So I'm saying I'm going to draw that ray for the angle. We'll pretend that it's through that point. And from that point, I want to draw a triangle. So what I always do is from the point, I'm going to go down and connect it to the x-axis, and then you can kind of connect it over. And now we have a nice triangle. In that triangle, since it's the point 8, 15, the x is 8, the y is 15. The issue is I don't know what r is. So that's where we're going to use that quick little Pythagorean theorem idea to find the missing side. Then once everything is labeled, we can fill in. So this is kind of the rearranged formula. I like to just plug into just that good old x squared plus y squared equals r squared, just to get used to it, because you might be finding different variables in the future. So let's plug in what we know. X is 8, y is 15. I'm trying to find r. Calculators are my friend, so I'm going to grab mine. Please have yours handy. If you haven't gotten one, you have a week. 8 squared plus 15 squared is 289. Okay, and then since it's r squared, you do need to take the square root to cancel that out. And the square root of 289, is that 17? It is 17. You have to do a little bit of work with anything in trig. A lot of it is just plugging into formulas and then throwing it in your calculator. So just make sure you have them handy. So we actually have everything we need. I'm a labeler, like I just need to have things labeled. It makes more sense in my head. So I'm just going to remind myself, x is 8, y is 15, r is 17. I just found that. So now that I have all of those values, I'm just going to go back and refer to what my ratios are and fill them in. Sine is y over r. So in this case, it would be 15 over 17. So once you find it, you just kind of plug them in, you're done. Cosine is x over r, so that's 8 over 17. Tangent is y over x. You can see once you kind of have them, they're not bad. It's just looking back at your notes and seeing what's what. And once you have those original three, the other three you just flip. So cosecant, you flip sine, so that would be 17 over 15. Secant, you flip cosine. And cotangent, you flip tangent. And that would be your final answer. That's not bad. In the future, for these first few that we're trying, we're just getting used to it, so we'll do all 6. But I'm not gonna always make you do all 6. It gets kind of annoying after a while. And so the first few we'll do that. But then sometimes you might just say what sign, and you would just fill it in and you'd be done. So I'll leave sorry, I need to take attendance as we're sitting here because I forgot. So you copy that if you need. Let me take it. Seven people we got in person. Sorry, if I don't send attendance, they yell at me. Give me one more second here. All right. Everyone was here today. It's you, headphone. Thank you. Bearing with me as I do my attendance. All right, so let's look at one more. We'll kind of start it together. You guys will finish it, and then we'll have one that we'll add steps on as we go. My main goal. All right, I'm drawing a little picture. I have 2 sides, so I need to find the third. So that's where that little formula comes in handy. And then once I have all 3 sides, I'm just filling in some trig functions. These are things we use for the rest of the year. So it's just, if you're confused on something, please ask. Don't sit there confused. That's pretty silly. So same idea. We have the terminal side. That's basically just where your ray is drawn. Of an angle is in standard position, and it passes through the point -3, -4. So I'm going to plot that point first. Just do it on the correct axis. So in the x, we're going to go -3. On the y, we'll go -4, and I'll put a point. So we are in a different quadrant. That's okay. So your quadrants will change. And that's where you're kind of drawing your angle, your ray through. But I want a triangle. This is trig after all. So when you're connecting, always connect your point to the x-axis. Just to be consistent. If not, some people go the other way and then it looks weird. That's a big mess. So it'll be consistent. We always connect it to the x. I like to fill in information. So this is -3. This is -4. I don't know r yet. So r is always that hypotenuse. So once I kind of have my setup going, I'm going to find my missing side. I'm going to use x squared plus y squared equals r squared. Just little things for the calculator wise, when you plug in a negative and you square it, it has to be in parentheses. If it's not in parentheses, it will get messed up. So just make sure parentheses are something you're always using when there's negatives. The reason being is when you square a negative, it should turn positive. So -3 squared is 9. -4 squared is 16. Or you could just throw it in your calculator. It will come out to 25. And r is going to be 5. If you remember back in the day, 3, 4, 5 triangles, that's all this is. A special right triangle. So I have everything I need. Once again, I just like to label. So x is -3, y is -4, and r is 5. So given that information, can you try to fill in your 6 trig functions? And if you need help with anything, now is a good time to help. I'm happy to help you from a 6-foot distance. For now, just look right at the top of your paper and say, I don't know the 6 trig functions. We learned them 5 minutes ago. I don't expect you to know them, but you should be able to refer back. Excuse me.
Shall we use that real quick?
Yep, go ahead, just grab them. I'll give you one more minute. Shouldn't have taken too long, hopefully. All right, so let's fill in. So, sorry, the glare is terrible. So sine, which she's getting used to, is y over r, -4/5. Cosine is x over r, so that's -3/5. For tangent, please make sure it is y over x, which is -4 over -3. And I would expect that you would say, oh, 2 negatives, you should rewrite it as a positive. So just little things like that. I would expect that you're simplifying. But once you have those, you're just flipping for the other part. So that would be 5 over -4. Or if the negative's out in front, that's fine as long as it's somewhere. 5 over -3. And then this one, I'll just flip to positive, that would be 3/4. Does anyone have any questions with once we found the information, how to plug it back in? Once again, trig is just plugging in. So for now, just keep your notes organized. I'm gonna let you use the notes on most things at this point, just because of the way our schedule is. So the more you do now, the easier your life will be later. Just kind of keep them together. Get a notebook or something and do all that stuff. So I'm gonna have you try one on your own. So you guys are gonna try 2. And then we're just gonna look at 3 quick, and then that's really gonna be it for the day. So the terminal side of an angle, so this is, all of them are set up the same way. So you're gonna plot the point 5, -12 first. So make sure you're in the right quadrant. Gonna try to kind of draw your triangle. Okay, what sides do I have? You're gonna try to find your R using your Pythagorean theorem, and then you plug it in. So you guys, to the best of your ability, if you need help, I can help you. You are trying number 2. And then there's just one thing I want to point out to you for 3, and then we'll wrap it up for the day. Not too bad. Excuse me. Okay, about 1 more minute. We'll look at that one, and then there's just one thing I want to point out for number 3, and then that will be our wrap-up problem. Oh, goodness gracious. All right, so let's try that one. And then there's one that's saying a little bit different about number 3 I wanted to point out to you. So I always like to do just a quick little sketch. This is going to be useful as we move forward because we're going to do some stuff with different quadrants. So on the X, I'm going to 5. The Y, I'm going to -12. So I'm about right here on the 4th quadrant. I'll draw a ray through that represents my angle. And then I'm going to connect that up to the X-axis and over to get my nice right triangle. I know that's 5 and that's -12, but I don't know what my R is. So I'm going to plug in. I have 5 squared plus -12 squared. Make sure that's in parentheses when you use your calculadora here. That gives me 169 equals R squared. So R would be 13. So just make sure you could get that R. I'm a labeler, so I'm going to say, remind myself, X is 5, Y is -12, and R is 13. And now I can plug in. You can just refer right back up to your first side there. So this is Y over R, so -12 over 13. Cosine is X over R. Tangent is Y over X. And then once I like those original 3s, the other ones you just flip. So that's 13 over -12. That's 13 over 5. And that's 5 over -12. Okay, you please take a second and check what you did. Are there any questions on that problem? That's just too good. Okay, one more thing and then we're done. One more thing, I just want to quickly look at 3. And show you one part, and then we'll kind of wrap it up and see if there's questions, comments, concerns about anything. So we do the same exact thing we've been doing. So the nice thing is the steps are the steps. They don't really change. I'm going to sketch this angle. What I notice is it's going through 1, and then the square root of 3. That's somewhere between like 1 and 2, right? So you don't have to be exact. I don't want you to like go and as long as it's in the right quadrant, you're good. So I'm going to estimate it's about right here. Doesn't have to be perfect, quick sketch. So we have a nice angle. We're going to draw a triangle down. just to hit that axis. Nice right triangle, where the x is 1 and the y is square root of 3. I need to find r, so as you can see, the steps are basically the same. We're just changing the numbers. So it's getting used to what you're plugging into. So we get 1 squared plus square root of 3 squared equals r squared. I put it in parentheses just to remind myself I'm squaring the whole thing. I know that 1 squared is 1. But does anyone know what's the square root of 3 squared? It's just 3, beautiful. So what happens is when you have a square root that's being squared, those cancel each other out and you're just left with a number underneath. So you're just left with 3. You can also use a calculator. So just use the parentheses if you're doing it. And if you're having issues with your calculator, let me know. Some of them can be a little tricky to plug into. But the square root of 3 squared is just 3. 1 plus 3 is 4. Okay, so that's not bad. R is 2. So once again, I'm just going to remind myself, x is 1, y is square root of 3, r is 2. That's the basic information I need to plug in. So I'm going to start plugging away here. Sine is y over r, so that would just be square root of 3 over 2. Cosine is x over r, so that's just 1 over 2. Tangent is y over x. So that's square root of 3 over 1. If something's over 1, I'll just write it as the square root of 3. So here's where we're going to have to kind of think a little bit. When I do cosecant, I would get 2 over the square root of 3. So I don't know if you remember this from any of your past classes. If you don't, that's okay, because that's my job to reteach you. But when we're giving an answer that has a radical, which is just a square root, you cannot have them in the denominator. Okay? So it's just one of those math rules, super fun. But the rule is, when I give an answer, I don't want a square root in the denominator. So the way we take care of it, and we will do this a lot, so today's just kind of an intro and we'll build up of it. If you have a square root in the denominator, you are going to multiply. And you are going to take whatever's in the denominator, which we have the square root of 3, and you're going to put it over itself. So if this is the square root of 3, you do square root of 3 over square root of 3. If you're going to change to something else, you would do that over itself. And the reason we do that is now when I multiply across, 2 times the square root of 3 is 2 square root of 3. The square root of 3 times the square root of 3 is the square root of 9, which is just 3. So the reason I do that is now in my answer, I don't want a radical in the denominator, and it took care of that for me. So we will go over that step a whole lot more. So for now, just write it down. It actually comes up again when we do cotangent, so I'll go over it one more time. But for secant, that would just be 2 over 1. We can just write that as 2. Now cotangent, same thing's going to happen. When I flip that, I get 1 over the square root of 3. I do not want a radical in the denominator. So the way I take care of it is I multiply. Whatever's in the denominator, you put that over itself. And then when I go across, 1 times the square root of 3 is just 1 square root of 3. And the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So what we're doing, same exact steps, there is a little bit more simplifying to it. So we're just going to do our best when little things like that pop up, and we will be practicing with that more as we go. We do a lot of things with radicals, with square roots that pop up quite a bit. So we will just make sure as we are adding that stuff that I re-explain it and we do a few problems, and then you can see if you have any questions. Any problems or issues or questions on that stuff?